The Arctic, a severe and hard-to-reach region, one of the most sparsely populated parts of the Earth. However, in recent years, there has been a surge of interest in the Arctic. This region is turning into an arena of clashes between geopolitical interests of different countries. Indeed, the Arctic is a real storehouse of natural resources and, first of all, of raw hydrocarbon deposits. According to the experts, 13% of the world's undiscovered oil reserves and 30% of undiscovered natural gas reserves are hidden under the Arctic ice. At the same time, more than 90% of the natural gas reserves of the entire Arctic are concentrated in the Russian sector. In accordance with the energy strategy of the Russian Federation for the period until 2020, the development of oil and gas fields on the shelf of the Arctic and Far Eastern seas is one of the most promising areas in the development of a raw materials source for industry. But the bulk of the Russian shelf, promising for oil and gas, accrue to the freezing seas with a severe ice regime and harsh climatic conditions. Exploration of the water areas of the Arctic seas under complex hydrometeorological conditions requires the creation of appropriate unique technologies and engineering tools. And here is where the knowledge, experience, and achievements of researchers and engineers of Far Eastern Federal University and its School of Engineering can come to help. The study and development of the ocean in the Arctic zone of Russia is one of the priority areas in the activities of Far Eastern Federal University. In 2014, within the framework of the FEFU Competitiveness Enhancement Program, the FEFU School of Engineering established the International Research and Education R&D Center, Arctic. Its main goal is to become a center of excellence in the field of Arctic technologies for the development of the world's ocean resources, and which is capable of carrying out a full range of engineering services, providing scientific support for projects on the shelf of the Arctic and subarctic seas.
The state, the government, and the president pay great attention to the development of the Arctic. The Arctic becomes the focus of attention not only in our country, but in the whole world. It is about security, resources, and the Northern Sea Route. Nowadays, as many as 10 centers of the Ministry of Emergency Situations are being established there to ensure the safety of navigation and work in the Arctic zone. Major projects are being implemented to develop gas fields in Yamal, to build natural gas liquefaction plants, and other projects. The purpose of establishing the International Research and Educational Center Arctic was to build a team of FEFU-based highly qualified engineers capable of solving various tasks for the development of the Arctic shelf.
Its mandate includes the basic and applied research, R&D, development of innovative technological products, and rendering a full range of engineering services. Far Eastern Federal University has accumulated a wealth of experience in scientific research and technological solutions for the development of oil and gas fields on the continental shelf of the ice seas. The staff of the engineering school has been successfully conducting research in the field of ice mechanics and ice tribology since the late 70s of the last century.
Our team has been engaged in research in the field of ice mechanics for over 40 years. This is linked to the discovery of oil and gas fields on the shelf of the Sea of Okhotsk in the northeast part of Sakhalin Island. At first, it was Soviet projects until 1991, and then we became the participants of Sakhalin projects that were carried out by international corporations. Complex theoretical and experimental studies were carried out, which allowed adopting well-founded design decisions on the structures of oil and gas platforms and their protection against ice impacts. In recent years, our team has been actively involved in solving ice and geocryological problems of developing oil and gas fields on the shelves of the Arctic seas.
The main research areas of the Arctic International Research and Education Center include the development of fixed and mobile oil production facilities, the development of technologies for underwater and floating oil production systems, safety monitoring of marine engineering facilities in the Arctic and on the continental shelf, and the development of feasibility study methodologies for oil and gas gas projects on the continental shelf.
Within the framework of our research activities, we have developed several mathematical models of the ice load on structures that led to the development of several software packages for calculation of ice loads and the abrasion effect of the ice cover. In addition, we have developed a model for calculating the ice loads for various types of marine engineering structures. These models have been implemented in software packs that are used in engineering design and research activities. In particular, the software for calculating the abrasion effect of ice cover on offshore hydraulic structures was used to calculate the thickness of the ice protection device on the Arkutan Dagai offshore oil production platform, nowadays Rakat, that was installed on the Sakhalin shelf.
Despite the relative youth, the Arctic R&D Center has modern laboratory facilities for education, research, and business activities. The modern equipment for research and experiments has been purchased. New specific equipment was developed, patented, and implemented by the specialists of the center.
We expect the delivery of the equipment developed by us, which will be used not only for educational purposes, but also for the implementation of our research and engineering, including the development of normative documents. One of the problems that the Department of the Arctic International Research and Education Center is dealing with is the study of the abrasive effect of the drifting ice cover on structures and the resistance of materials to this influence. We want to set up a full factorial experiment with the use of new equipment which has almost no world analogs.
Currently, the Arctic International Research and Education Center includes 4 research laboratories specializing in ice research, design of marine engineering structures, modeling of complex engineering systems, development of new materials. Another structural unit of the center is the Design Engineering Bureau, Streutel, which is engaged in the design of various types of structures, including Arctic structures.
The staff of the Arctic International Research and Education Center is 54 people of different ages and various specializations. It includes the students who work as laboratory technicians and perform their own small-scale research. They are young specialists, postgraduate students, candidates and doctors of science, senior research fellows and professors. In other words, we cover the whole spectrum, from student to professor level. The core of our team consists of the specialists with extensive experience who have been long engaged in basic and applied research. There are also a lot of young specialists. We have postgraduate training program, including 2 master's degree programs taught in Russian and in English. These programs allow us to train young researchers who will participate in our projects. We work on any project as a team. This is not to say that only young people are capable to deal with new challenges. Young people are not always able to see the whole problem. But at the same time, the joint work of both young staff and the experience of the older generation allow us to achieve more significant results.
The FEFU Arctic International Research and Education Center cooperates with major Russian oil and gas producers. Specialists of the center conduct research and work in the field of sea ice mechanics, methods for studying its properties, determining ice loads and impacts on marine engineering structures in the main areas of Arctic engineering on the shelf of the northern seas, the development of a referral information system for Arctic engineering, and the KPI evaluation system for offshore fields development. The scope and amount of work are constantly increasing. In spring 2017, a group of researchers from FEFU spent 2 months in the Gatanga Bay area under the contract with Rosneft Oil Company, studying permafrost conditions in subsea areas of the Arctic shelf. This is necessary for exploration and implementation of the initial stage of a new field development in the southwestern region of the Laptev Sea. On-site researchers conducted exploratory well boring directly from the ice cover, during which more than 1,000 soil samples were collected.
Our task was to drill 12 wells with a total depth of 600 meters to explore bottom sediments in Nordvik Bay, with the prospect of building an oil production platform here. In the field stage, we have selected the core samples. These are soil columns of cylindrical shape. Most of the tests were carried out on site in the field. Some of the tests were conducted in the laboratory facilities. Some samples were sent to Lomonosov Moscow State University, and some were sent to our labs in FEFU. Another part of samples was sent to Institute of Oceanology, named after Shirshov, which was engaged in determining the gas phase, primarily methane. Every day we would visit a drilling rig. The rig was on the ice. This is a unique drilling from the ice, and accordingly, every morning we would get into the off-road vehicle and go to this rig where drillers extracted the core. We were describing these drilling samples, packing them, and making the necessary measurements day and night. We have established 12-hour shifts. Some people had to work at night, another in the daytime.
The obtained results will help to determine the working conditions for prospecting and exploratory drilling and for further field infrastructure development. They will be used in the design of the maritime infrastructure and the hydrocarbon transportation system. In the words of the participants, such expeditions are not only bright impressions, but also invaluable experience.
All this was completely new to me. This was my first time in the Arctic in winter, and I saw the northern lights for the first time. Most importantly, I have acquired completely new knowledge that will be used not only for scientific purposes, but also in classes with students. In general, this expedition enriched me. I got a new experience.
Far Eastern Federal University is actively developing international cooperation in the field of Arctic research. The Russian-Australian Center for Arctic and Antarctic Research was established jointly with the University of Melbourne. Along with the research, the universities plan to organize joint expeditions and conferences, to apply for research grants, to exchange teachers, young scientists and students, to launch a joint master's program. Besides, starting from 2017, Australian students have become permanent participants in the winter course Ice Mechanics.
I get to know about this winter course because my boss knows the Professor Becker, and he sent me here to learn more about ice, because in our university, at the University of Melbourne, we are experts on waves. We start working on the marginalized zone and problems related with waves and ice, but we are not experts on ice. So I'm here building up some expertise. And we do like weather forecasts all over the world, and it's a big problem.
In 2016, FEFU, in partnership with Harbin Polytechnic University, the leading engineering university in China, has founded the Russian-Chinese Polar Engineering and Research Center. Researchers of the two countries will jointly develop the design of ice-resistant platforms for the Arctic zone of Russia and the shelf of the Yellow Sea, build high-speed transport systems on permafrost soils, carry out the research on the longevity of concrete and the reliability of engineering structures in the polar zone, and estimate the ice load on vessels. FEFU and Harbin Polytechnic University also plan to intensify the exchange of students and scientists. Broad and fruitful cooperation has been established with other countries, universities, and companies.
We've established long-term relationships with leading international companies with great experience in offshore projects. These are Sakhalin Energy, Sakhalin 2 project, Exxon Oil Company, Sakhalin 1 project, Norwegian companies, Varner and Multiconsult. Our team has fulfilled many contracts under the Sakhalin oil and gas development projects in the period from 2000 to 2012. As a result, many of our graduates participate in the implementation of unique projects abroad. A good cooperation has been established with Varner Company. Every year, under this cooperative effort, 4 of our staff members, master's and postgraduate students, were participating in a 3-month internship at the company's offices in Oslo and Stavanger, including engineering company Multiconsult and the Norwegian University of Science and Technology in Trondheim. We have developed the English language master's degree program in offshore and coastal engineering. As part of this program, students, graduate students, postgraduate students, young researchers, and specialists participate in international exchange. For example, this year 2 international exchange students from Trondheim University, Norway, and one from the University of Hokkaido, Japan, studied for a whole semester at our master's degree program.
FEFU conducts and hosts numerous international conferences and forums. PACOM's international symposia were organized in Vladivostok in 2004 and 2012. In September 2016, the FEFU School of Engineering hosted the Polar Mechanics International Scientific Conference for the first time. Scientists from leading Russian and Chinese research centers discussed the most important achievements and projects in the field of polar mechanics, shipbuilding and ice navigation, hydrodynamics, and construction of Arctic infrastructure. One of the perfect venues for efficient collaboration between young researchers from different countries is the Ice Mechanics International Winter Course, which is held annually at the FEFU School of Engineering. The main goal of this winter workshop school are the acquisition of knowledge in the field of ice mechanics, involvement of students in research activities in this field, the talent pipeline development, the creation of an information platform for communication between national and international experts, the establishment of partnership relations with universities, research and technological centers from the countries of the Asia-Pacific region and other countries.
The main idea is to show that the knowledge that we can get about ice and physical phenomena can be applied in different fields of engineering. These are offshore structures, shipbuilding, ecology, and a full range of specialties, which in some way are related to the study of the Arctic and sea ice.
The Winter School is a 2-week course, which includes theoretical training, laboratory and field research on the ice cover of Narvik Bay on Ruski Island. The main language of the Winter School is English.
You know, the middle one there. I don't know if we did measurements, so yeah.
In recent years, China has greatly developed its ice technology, and that is why I came here to get new knowledge about the properties of ice. The most interesting are experiments and tests. I think if someone wants to be engaged in ice technology, it is necessary to conduct tests with real ice. Theory alone is not enough, and from this perspective, the ice mechanics course is very useful.
The most useful in this course is field research. You can learn the theory at home by textbook, but you will never learn engineering without practice. That's why I came here. In addition to practical classes, I learned a lot of interesting things from colleagues and school participants from England, Norway, Mexico, and India. And this is very important for me.
It is very important knowledge. We are doing now so many experiments about the ice loading as well. We doing about the ice properties. We studying the ice properties from strength, from salinity, from anisotropic, properties of the ice, temperatures, and the stresses on ice, like biaxial, uniaxial, triaxial stresses, and that's what we study, and that's why I want some information, some structures about this ice that will help me for my thesis and to progress more as well, and maybe in near future to collaborate with the school as well, because with the UK we have not got all the facilities like this school, they get the equipment.
There are different skills about ice mechanics, the mechanical properties, how people do tests on ice, because it's very different from my background. It looks like I'm going back to my bachelor course when I did geotechnics and structural engineering. But it's very good, especially for me that I come from Australia, to have hands-on on the ice, because we don't see much ice around there.
The participants of the Ice Mechanics International Winter Course are students and postgraduate students, specialists from international and Russian universities and companies. In just 3 years, 78 students from 13 countries across the world became the participants of the Ice Mechanics Winter Course.
Over the last 3 years, we have expanded our relations with various educational and research organizations that are willing to send their students, postgraduate students, and masters to our winter course. We have received a number of statistical data on ice loads and impacts and on strength characteristics of ice in Amur Bay in Vladivostok. By utilizing these statistics, we plan to obtain a number of dependencies that can be used both in computational models and in new software applications which nowadays are not enough to be used directly in calculations of ice loads on structures.
Currently, Far Eastern Federal University is promoting the project of building up the FEFU Arctic Campus, a research and educational site located directly in the Eastern Arctic Zone, designed to implement the Arctic-oriented educational programs. At the premises of the Arctic Campus, it is intended not only to implement international educational programs and projects, but also to conduct research by international teams.
We are increasingly expanding the spectrum of the Arctic research, and we involve other centers and departments of our university. Now we are creating an interschool center that will coordinate this activity. The fact is that there is a wide range of topics in the Arctic research today. They comprise not only technological, but also social problems and legal support issues. For example, the legal experts from FEFU are engaged in this, as well as economists, biologists, sociologists, and physicians. Basically, all areas of expertise could be in demand. It is necessary to explore the Arctic and to create comfortable conditions for life and work. We need to promote the ideology of commercial development of the Arctic. Therefore, there is a field of activity for everyone.